get executed on separate threads, which means at some point you might want to cancel a particular task, and the task parallel library provides explicit mechanisms for doing exactly that. So let's take a look at how it works. Let me make a task T. I'll make a new task which basically runs forever. So I'm going to have a task which does something forever. I'll have a counter I starting at 0, and then while true, I'm basically going to output that counter and increment it as well. So I'll have console.writeLine. I'll have the counter being incremented and a tab character. So we're doing this task forever and ever, and you can never stop it. So once I do t.start, the task will run to infinity. So the question is, how can I actually cancel the execution of this task? How can I stop it? Okay, so in order to support cancellation, the task parallel library gives you two things. It gives you a cancellation token source and cancellation tokens. So the first of those is a cancellation token source. Let's make one. Here's a cancellation token source. Now from this you get a so-called cancellation token, and the token is exactly that which you provide into the body of the task when you want to cancel the task later on. So essentially we say something like var token equals cts.token, and it's exactly this token that is provided here, for example. So we provide a token. You can see that it's in the overloads there is a cancellation token. That's exactly what we're providing. So now that we've provided a cancellation token, we can call cts.cancel if we want to actually cancel the execution. So here I'll do a console.read key, so we pause on the input, and whenever you press a particular key, we're going to cancel the whole thing, cancel essentially the task. However, you have to understand that in TPL, cancellation is cooperative, which means the task that you've made has to be explicitly aware of the fact that it's cancelable, and it has to perform certain actions to actually cancel itself. So there are two ways of canceling your execution. One of these is kind of soft failure. Remember, we're in the while true loop. We can always do a break or a return, and then we're out. We're done with the task. So that's one of the ways of doing it. What I can do here is I can look whether cancellation has been requested on this particular token. So I can essentially say, well, if token dot is cancellation requested, then somebody wants to cancel execution. In this case, I can just do a break. Otherwise, yes, I'm going to continue outputting those characters. So that's one of the ways of doing it, and let's actually take a look at how it works. Let me execute the thing. So as you can see, we get a never-ending stream of numbers. However, as soon as I press a letter, for example, we have the execution stopped, because essentially I called cts.cancel on that cancellation token. So we input a character, and then cts.cancel essentially cancels the whole thing. So token is cancellation requested gets set to true, and we break out. So this is the kind of soft exit out of a task. There is a more canonical way of getting out of the whole thing, which is to use exceptions instead, and that's something that TPL actually recommends you do. So there are two ways of doing it. One of those ways is as follows. Instead of just breaking out, the kind of soft exit, what you do is you throw an exception. And specifically, the exception you throw is an operation canceled exception. So that's a canonical way of actually jumping out of the whole thing. And no, it's not going to really cause exception on the high level. So let me actually execute this, and essentially as soon as I press something, the task has canceled, and we're essentially done. There is no problem here. It's not like we just threw an exception which got propagated all the way up, because we're expecting this kind of exception, unlike some other sort of exception. So that's one of the ways of canceling tasks. Another way is when this line and this line get merged together. That's just a syntactic shortcut that TPL gives us. So instead of those two lines, the if check and the invocation, what you can do is you can say token dot throw if cancellation requested. That's basically a combination of those two things. First of all, it checks whether somebody requested cancellation, and if somebody did request cancellation, then it throws that exception. The end result is absolutely the same, and this is the canonical way of stopping the execution of a task. Now, there is a difference in terms of the status that you're going to see if you take a look at the status of the task after it's been executed, because if you throw, then yes, the task knows that it's being cancelled. However, if you don't throw the exception, the task isn't going to know that it's being cancelled. It's just going to tell you that it completed successfully. So the question is whether or not you want to actually be notified of the fact that somebody cancelled the task. It's really a design decision. However, this is the canonical way. This is the way that TPR recommends you do this, because then you have a record of the fact that somebody canceled this particular task. And also when you have several tasks tied to a single token, you can better figure out what happened, whether the task completed successfully or whether somebody generally canceled it. Okay, so one question that we might want to answer is how can we monitor when a task is cancelled? How can we be notified about it? And once again, there are different ways of doing exactly that. So one of those ways is you can basically subscribe to an event that's available right on the token. So you can say token.register, and then you can provide some sort of function which actually handles the situation when somebody wants to cancel on the token source. So in this case, I'll console write line and we'll say cancellation has been requested. So that's essentially a function that's going to be executed as soon as somebody does cts.cancel. So that's one of the ways of doing it. Another way, which is also very interesting, is to basically wait on the cancellation token's wait handle. It's a bit more complicated, but I do want to show it to you. So let me actually write this down. So I'm going to spin up another task, task.factory.start new. And this is going to be a bit confusing, but I'll go slow and actually explain what's going on. So one of those synchronization primitives that we'll talk about later in this course is called a wait handle. And it just so happens that a token that you're using to cancel tasks is equipped with such a wait handle. And essentially the idea for this wait handle is that you can wait on something else to occur. It's kind of like an event. It's kind of equivalent to having a subscription to an event here, because essentially when you call register, you're subscribing to an event that happens. Here, the idea is that you take the token's wait handle explicitly and you say, I'm going to wait. I'm going to wait on this handle until somebody cancels the token, until somebody actually invokes the cancellation. So as soon as cancellation is invoked, this function call, which is actually blocking, will release and will allow you to do whatever it is you want to do. So in this case, I can once again console write line, and I can say that the wait handle has been released and therefore cancellation was requested. So let's take a look at what happens when we execute all of these. Okay, so I'm going to press a key, and you can see the output here. So we have the output cancellation has been requested. That's from that additional call that we made, the explicit kind of notification. And then here is the wait handle call. Notice they don't have to be in any sort of sequence. They can happen concurrently, so to speak. So that's two of the ways in which you can actually monitor that somebody wants to essentially cancel the task. The last thing that I want to show is a bit more complicated. It's to do with composite cancellation tokens. So let me get rid of everything that we've written so far, and I'll show you how that works. So essentially, the idea is that you can have several cancellation token sources. For example, you might have a token source for cancellations which were planned. So you say planned equals new cancellation token source. But you might also have a cancellation token source for preventative measures. Preventative new CTS. And you might also have a cancellation token source for emergencies, like running out of memory, for example. So I'll say emergency equals new CTS. Okay, so we have different cancellation token sources. What we can do is we can now specify a token source which reacts to any of those three token sources being triggered. Essentially a kind of paranoid mode. So I can say var paranoid equals, and then I can do cancellation token source dot create linked source. So essentially what this does is you can take the tokens from the planned, preventative, and emergency token sources, and you can feed them into a new token source. So Paranoid is going to be a cancellation token source, which essentially, if you get a token from Paranoid, that token will cause cancellation when you trigger, when you call cancel on either planned or preventative or emergency. So here you specify the tokens. You can say plan.token, preventative.token, and emergency.token. And you've now created this kind of linked situation. Okay, so how do we actually do all of this? Let me make a new task. So I'll once again task.factory.start new. Let's make a lambda here. So I'll have some counter, and then while true, I'm going to basically console.writeLine as before. So we'll write line with a dollar, we'll write line I++ followed by a tab. Okay, so now what I'm going to do is I can actually check whether cancellation has been requested on the token from this paranoid merger of the cancellation token. So essentially I can say paranoid.token.throw if cancellation was requested. So I'll output this. I'll put a sleep in here just so we don't get a massive strolling stream of numbers. That's annoying. Thread.sleep for 100, for example. Let's have it as 1000. Okay, so here I'm executing this task. I'm providing paranoid.token. So that's the token from the linked token source. Now, what does this mean? Why did we do all of this? Well, essentially what this implies is you can now request cancellation on either planned or preventative or emergency token sources. And because we have a token from a linked token source, that will stop our execution. So it doesn't matter what I do here. For example, I can say emergency.cancel. Emergency.cancel. And this would actually cause paranoid token to cause the stoppage of this because it's linked, because essentially paranoid is linked to both planned and preventative and emergency. So if I had here planned.cancel or emergency.cancel, it would still stop the thread. So let's actually see how it works. I'll once again put a console.read key here, and we can run this and see what we get. So here we are with a slowly filling stream of numbers. As soon as I press return, you can see the program is done because we've essentially canceled, and it doesn't matter which of these cancellation token sources we cancel because they were all linked to the paranoid token, which is exactly what we used in the creation of the task. And this is how you cancel tasks.